Welcome to section 3, Creational Design Patterns. In last section, we got to know about different categories of design pattern and the philosophy behind its categorization. In this section, we are going to explore all design patterns which comes under creational design patterns. First, we will look at Singleton design patterns, which ensures only one instance of an object is created. Then prototype design pattern creates a new object from an existing object. Builder design pattern used to create complex object. Factory method creates object without specifying the exact class to create. And last, abstract factory design pattern, which allows for the creation of object without specifying their concrete type. Singleton design patterns. In this video, we are going to take a look at what is Singleton design pattern with its definition and intent. When to use Singleton design pattern, real life example with UML diagram, code walkthrough, and quick summary with its pros and cons. What is Singleton design pattern? The Singleton pattern is a gang of 4 creational design patterns that restricts the instantiation of a class to single object. This is useful when exactly one object is needed to coordinate actions across the system. Intention of Singleton design pattern. Ensure a class has only one instance and provide a global point of access to it. Encapsulate just-in-time initialization or initialization on first use. When to use Singleton design pattern? When application needs one and only one instance of an object. Additionally, lazy initialization and global access are necessary, and state of objects needs to be shared across application. Logger and print spoiler are candidate application for Singleton. Let's take a real-life example. There is a saying, too many cooks spoil the broth, and I added next line, single cook can make it tasty. Imagine there are several cooks which are trying to make a broth in a chaos or in an uncoordinated way. When one cook adds salt, other was doing something else totally unaware and later on added salt again without realizing salt was added before. In technical terms, it has no knowledge of shared resource of the object. However, when Singleton pattern was applied, the state was shared and the broth became tasty without additional salt by virtue of the single cook or the Singleton design pattern. Let's try to see this in a real code. Here is the sequence diagram. We have a client class. Client class asks for the object of the cook. So cook create the instance if it doesn't exist. The responsibility of cook is to create its own instance and then it returns it to the client. On next subsequent requests, the cook returns that single object instead of creating multiple objects each time. Let's understand in the code. So we have a module called as patterns here. It has its module info.java which describes the module. So we have a cook class which is simply making a broth and it just checks the salts. If not's been added, it will add it. So that's how it is. To make the broth, we deployed 3 cooks so that the soup can become faster or the broth can become faster. Let's try to run this. But the problem is too many cooks have spoiled the broth. The salt has been added 3 times. So we should do something about it. Now to make our cook as Singleton, first thing is we'll make the constructor private, which will not allow from outside this object creation. Then how would the object create? So we need to self-create the object inside the class itself. So we'll expose a method which should be public and then it should be static, and we can call it as get instance, and it is going to return the object of cook itself. So before we return, we need to make a variable or a member which we can make as private cook, and we can say unique we can say unique instance, and we will assign it to null. Now we will return the unique instance from here. So when we return, we have to make this as static because our method is static, so our variable has to be static. Since our method is static, our variable has to be static. So let's try to modify this code. What we are going to do is, instead of creating the object here, we know Singleton is a creational design pattern. So we'll just call our instance, and this instance is going to create the object. So we are removing new from here. You will see the same pattern in all creational design patterns, that you don't have to call new. Cook method will create the object and then it will assign it to here. Now there is one condition, since this is unique. If we run the code now, we will end up with the null pointers which we expected. So here is the key, that you need to compare it. If your unique instance is null, for the first time it would be null, like at the first usage. Then you create and assign the object reference with the cook object, something like this. Now if you will run, everything should work fine. And the best part is, you are adding salt only one time. So you have created the single instance. Now you might have like 3 cooks here, but they are coordinating because all these are relying on this added salt method. So if you call it again or whenever, this seems coordinated. So what we learned here is the state is shared. There is only one object which gets created, and then that has been used. So your broth would be super tasty. So too many cooks spoil the broth, but if you have single cook, it might make it tasty. So if you will go to the repository, you will see that there is a fresh branch called as Singleton, which is there. So just in case if you want to access the code, you can go there and then you will see the commits. The understanding problem will be the first, and this one the solution. So you can just browse through it. From your IDE, you can also go back and forth. For example, this is what we had, for the solution. If you want to understand the problem statement, just go there and check it out. Check out revision. This will bring you the problem statement. And the commit number message are also explanatory. This is the problem, you need to go to solution. Just check out revision and you will see the solution. So this will help you in learning better. So friends, I have made another module called as pattern bonus, in which I'll be giving you few more examples and corner cases to learn more on that. I'll quickly go through and explain in this scenario, but in interest of time, I would request you to go through it, run the code, fork it on your local, play around with it, try to break code, repair it, do whatever. The more you do, better you learn. So the scenario is eager instance loading. So this is an example wherein we have the Singleton eager instance. We are trying to get the unique instance and doing a count. Let's run this. And it runs fine here. So let's see how it has been implemented. So eager loading, you don't have that method wherein you check if it's null or if it's not null. You just have a static final object reference wherein you create the object upfront. So whenever the class gets loaded, it's there and then you can use it. You don't instantiate it. So that's why it's eager. Its performance is fast. Like on the single or the first usage, you skip on the object creation process and it's ready to work. So in the lazy loading, what we did is, you don't have the object upfront. However, the object is created whenever it's been first used. For example, we'll see here that you have this instance. If initially you have this null, but whenever you need it at first time, if it's not there, if the unique instance is equal to null, then you create the instance. So profit is you don't occupy memory upfront. At the first time, whenever it's used, the instance is created. So first time there will be a very minor more usage. So first time there could be a little performance hit. So first time when the instance is getting created, it could be little bit slow, but not always, like not in the subsequent uses. Now we'll see the example of thread. So thread safety, let's see that. So what we are trying to do here in this thread issue is we are trying to create 3 threads, and all of these 3 are trying to create the instance and do the counting on them, and then we start them, right? So there could be a chance that once first thread goes, and then it might sleep for a while and second thread comes up. So at this time unique instance would be null, and then first thread creates the unique instance and another thread takes up from there and create another instance. So this thing might break our pattern and say, how come it's singleton? Because 2 objects has been created, which means both objects can have different states altogether and stuff like that. So just to avoid that and be on safer side, we can use the synchronize keyword, which will take care of the threads. You can always do thread locking and all that. I have mentioned the double locking example, so feel free, go ahead and look into that code. But if you are using concurrently, if you have more concurrency in your app where you are trying to implement this singleton pattern, I would say you can use synchronized. It has its pros and cons. It would slow down minor, but if you are okay with thread safety, you can apply that. If you don't need it, you don't have to get this. Thread safety, so if you think that thread safety is essential in your app because a lot of concurrent users might use this, then you can implement synchronized keyword. Otherwise you will be fine as long as the unique instance is created and it's referencing just single instance. You should be good. So everything has pros and cons. Based on that you can take the call. Summary. Singleton is good for applications where single instance and global access with shared state is required. It might save a lot of unwanted object creation. However, there are some cons, like they violate the single responsibility principle by virtue of the fact that they control their own creation and life cycle. They carry state around for the lifetime of the application, which causes issues in testing, as each unit test should be independent of each other. Reflection might break singleton and several instances can be created. However, Java 9 takes care to prevent reflection from breaking singleton by disabling the reflection in the configuration.